New nuclear is on the horizon and can provide an effective zero-emission solution for heavy industry and transport, which are currently responsible for as much as 30% of all greenhouse gas emissions. To achieve this, nuclear needs to move from economies of scale to economies of numbers. Nuclear power is a true zero-emission technology and it needs a mass market. Ocean transportation is a vital component of global trade, with over 85% of commodities, industrial components, and durable consumer goods transported at sea. Of the world's 100,000 ships, just 7,300 consume half of all marine fuels, and thus emit 50% of all greenhouse gases from ocean transportation. From 2050, the UN has mandated that ocean transportation must be emissions-free. In 2018, Core Power was formed to bridge the gap and build the market for advanced nuclear technologies in the maritime industry. Today, Core Power partner with leading international companies to deliver durable, zero-emission energy solutions for floating industrial production and deep-sea shipping, while also co-funding developments of advanced nuclear energy technologies which are appropriate for maritime use and lead the work to build commercial civilian nuclear solutions for shipping. Our industry engagement, regulatory consultation, and design and engineering will result in a competitive, true zero-emission power system for the future of maritime from 2030. Core Power are actively participating in the work required to modernise regulations for maritime and nuclear, and to pave the way for small-scale nuclear to take its rightful place as a key pillar of global sustainability.
Hello everyone, and a very warm welcome to you all for Core Power Hour number 6, the latest in our series of virtual programs. This is one of our free-to-attend events, learning events, with each of these online programs covering a separate topic on new nuclear for maritime. The idea being that this provides a taster as to part of the learning element that is encapsulated inside our client program. Just to advise you that this program is being recorded, and we'll be able to make a copy of the recording available afterwards. So if you would like one, or if one of your colleagues would like one, please let us know. And the same, in fact, goes for all of our previous Core Power Hours as well. A final small housekeeping point that we would respectfully ask is that you don't take and especially reuse screen grabs from any of the presentations that you'll see today. If there is a specific image that you'd like to see again, please contact us offline and we'll do our best to assist with that. I'm Toby Menzies. I'm the Director of Business Development for Core Power, and I'm going to be your host for today's program. Now, today's topic is going to look specifically at the potential that new nuclear for maritime has in the United States. So it's quite a broad topic. There are several elements that we're going to introduce first in sort of a macro picture, and then separately look to head back into those in a little more detail later on. For example, we'll take a slightly closer look at some work that's happening under the Department of Energy's Advanced Reactor Demonstration Program as to how advanced nuclear technology is being developed and supported in the United States, and how that technology could be a catalyst that could change the outlook for US shipbuilding, and also an overview of the US regulatory landscape that surrounds all of this. So the format today is a little bit different, not drastically, but slightly different. So following each one of our talks, there's going to be a short panel discussion, and immediately after that, the opportunity to then answer some questions. So if you do have something that you would like to ask, or something that you'd like to hear more about or have clarified, as usual, please use the Q&A function on the bottom of your screens there, and we'll do our best to get through some of these in each of these shorter but more frequent Q&A sessions. Some of the questions we may be able to provide a quick written answer to, and others we'll try and answer in person. Now, joining me, we have a brilliant blend of youth and experience, and in no particular order, we've got our Chief Executive, Nicole Bowe, our US Regulatory Analyst, Sanjana Shashikumar, and last but not least, our Director of Analytics, Dr. Rory Megginson. Welcome to all of you. Now, Mikhail, I'm going to ask you to give us the lie of the land as you see it to start our program today. It sort of feels like the United States occupies a relatively privileged position, shall we say, when it comes to advanced nuclear technologies. And with that position, of course, comes opportunity with it. But I wanted to ask you, I mean, do you also see it that way? What is it about the overlapping of maritime with advanced nuclear that could allow the US to take advantage of those opportunities?
Toby, I think it's really a combination of challenges and opportunities. So if we've got a leadership position that's being, if you like, sought by the United States on the new nuclear side, that's really the wish of the US government to sort of reclaim that position as the leader in building new nuclear, investing in new nuclear, and reclaiming that #1 spot that they've gradually been losing to the Chinese and also to the Russians over the last few decades. That's all very well for a domestic market, but if you're going to try to then influence the way things are done in sort of soft power, if you like, you need to be able to move that stuff around. You need to be able to get that exported, and you need to be able to move it to places where you couldn't otherwise reach. And then on the other side, you've got the maritime industry, as we all know from the last few years. It's an industry that not just needs to decarbonize, but it's also one that also is very largely dominated by Asia. So more than 50% of all shipbuilding at the moment, of course, is happening in China, which outstrips pretty much everything else in the world. So the opportunity here is really combine those two and see if we can create a new competitive advantage in the West for some of these things, with collaboration from those companies and countries around the world that wish to sort of take this forward. So that's really what I'm going to be talking about today. So let me just check, Toby, if you can see my presentation.
Yes, that works.
Very good. So really what I'm going to be saying this morning is really how this can be a disruptive technological catalyst for the US shipping industry. So this is new nuclear in maritime, really, in a nutshell. And it's not, I think I'd like to make sure everybody understands this, everyone's listening and is participating here today. This is not something which is the be all and end all. This is where it starts, right? If we're building technology in one place, it's licensed there, it's built there, it's prototyped there, it's demonstrated there, and the first sort of deployments are done there. So if we're going to do that combination of new nuclear and maritime, with American reactor technology, we really need to look at the US shipping industry, which I have to say is in a tenuous state at the moment. But first of all, maybe for everyone's benefit, because we've not done this before on the program, Toby, just to sort of set out what Core Power actually is and who we are and what we do. And I wanted to make sure that everyone just gets a brief introduction to that. Now, the company was founded in 2018, so that's just 4 years ago. We have 55 strategic maritime shareholders in the company. We don't have any venture capital or private equity in this company. It's all sort of by the industry, for the industry. And we've managed to achieve a north of $350 million market valuation in that short 4 years. So you can see there's a lot of momentum building behind that, and gives us the ability to invest heavily in these technologies. Our role is really to develop a market for new nuclear and maritime, as well as technology. We're developing that market for that and helping form the modernization of regulations around this so that it can actually happen. As part of that technological development, we have strategic alliances with key US reactor designers. So we're actually co-developing and co-financing this. And our strength and capabilities that allows us to do that is really that participation in the development of those US reactor technologies under the US Department of Energy's Advanced Reactor Demonstration Program, which is a large grant program, like I said, with the US trying to reclaim the #1 spot in advanced nuclear. And as part of that, we've built out our capabilities and become, I believe, widely recognized as a leader in this particular field. The main purpose of all of this, of course, is to make sure that the technologies that are being developed under these programs and for maritime are fit for purpose. They're not just, a nuclear technology, that they are specifically fit for purpose. So engineering, naval architecture solutions, regulations, and commercial customers is really our focus here. Our mission is to divide it into two. We pre-launch, so before we launch these products, of course, is co-development and finance of those technologies, developing those markets, like I said, and leading that regulation. But once that's done, once we've prototyped and demonstrated and deployed the first of these technological solutions, our role really changes. You know, our role is then to build a world-class manufacturing base for floating nuclear solutions. That means shipyards, that means ecosystems around manufacturing of systems, supply chains, etc. And then that strong workforce, quality training, solid management systems required to support that and create, if you like, an extremely high quality manufacturing base. Then moving on to mass manufacturing of these solutions so that we can get enhanced energy security, and we can of course do that with zero emissions, which is really the aim for the maritime industry as well. And of course, at the end of the day, you know, being a commercial company, being a private company, we'd like to make sure we make robust returns for our shareholders. The vision at the end of the day is really to create that integrated, investable, floating nuclear solutions company, the company that, you know, the market can come to get its solution and also be able to invest in, so that it's invested across the entire cycle. That means bringing exclusive technologies to the market, like I've described, you know, the regulatory pathway and those rules and regulations in place, as well as finance, leasing, service, and through life maintenance, and through the fuel cycle. That should relieve energy security, you know, through developing of these floating nuclear solutions that can be first deployed in the United States and then moved on to other places, like here in the United Kingdom and around Europe and other places. And that also then means building very strategic partnerships with customer investors. So our customer base and our investor base is all the same. And then, of course, once this is up and running, we would of course aim to create some liquidity.
Okay, looks like we've experiencing some technical challenges there, and we've lost Mikhail. And I also noticed that his slideshow wasn't advancing through the deck as we'd seen before. So maybe if he's able to reset his connection and come back in, that will actually be a benefit, and we can recap what's lost. If there is a complete technical breakdown, we can always sort of pass some slides around later on, so you can actually see the images. We'll give Mikhail a minute to maybe try and rejoin. Okay. Maybe it's best if we will reset the order a little bit and perhaps move on to Sanjana, and we'll reorder the presentation so Mikhail can slot in later. So I'm delighted to introduce now Sanjana Shashikumar. Sanjana is based in Washington, is regularly interfacing with regulators and customers there. So she's very well placed to give us a quick rundown on the US regulatory landscape. So I'm going to pass the baton over to her now. Now, Sanjana, you've been studying this for a little while now. How would you sort of summarize what you've learned during that time, and what do you feel is sort of the level of enthusiasm really from the different US regulatory bodies?
Yes, thank you for the introduction, Toby. When you speak about what I've learned so far of the regulatory environment, I've found that there is a very strong focus on protecting the American economy and ensuring American jobs. That being said, on the enthusiasm side, there is a lot of enthusiasm for advanced reactor technology and the development of advanced reactor technology. Part of what I will be speaking on today is merging that with the maritime industry and merging that with the maritime regulations that already exist. So with that, that's how we go. So like, as I said, today I'll be speaking on the regulations that are relevant to this technology. It's very broad. It goes over nuclear, environmental, and maritime regulations. Today, specifically, we'll be talking about maritime regulations regarding US flagged commercial nuclear vessels. I'll be discussing 5 of the major maritime regulatory bodies before going into a little bit more detail about the American market that already exists, precedent within regulation, and the opportunities that this technology could provide for American leadership on a global scale. So to begin, the Maritime Administration, also known as MARAD, under the Department of Transportation, is responsible for maintaining the health of the merchant marine. Functionally, this involves maintaining equipment, shipyard facilities, port infrastructure, and the reserve fleet of commercial vessels. They're also responsible for maintaining registries and conducting research and development with the intention of increasing the use of American navigable waterways. MARAD will play a very central role in the deployment and applications of these vessels within the United States. The Department of Homeland Security is the second regulatory body I'll be discussing today, but they play a very important role in regulating which flagged vessels can participate in trade and commerce along these waterways. The Customs and Border Protection Agency is responsible for regulating the Merchant Marine Act of 1920, a statute of federal law more commonly referred to as the Jones Act. In essence, the Jones Act requires that all goods shipped between U.S. ports must be done on vessels that are built, owned, and operated by U.S. citizens or permanent residents. The purpose of this regulation is to protect American commerce, the shipbuilding industry, and jobs, while limiting foreign participation and competition in the industry. While this framework may seem limiting towards growth, it can provide an opportunity to expand upon shipbuilding within the United States. These developed capabilities would set up the U.S. to replace the current aging Jones Act fleet, which I know McCall will go into a little bit more detail when he comes back online, and meet the rising demand for its application in a regulated market. The third regulatory body relevant to commercial vessels that I'll be speaking about today is the International Maritime Organization, also known as the IMO, and specifically their Convention on the Safety of Life at Sea, or SOLAS. SOLAS set the minimum safety standards for construction, equipment, and operation of merchant ships. And in particular, Chapter 8 set the international standard for nuclear-propelled commercial vessels. Current regulations only encompass vessels propelled by pressurized water reactors and are not reflective of the many advancements in nuclear reactor technology that have occurred and will come to fruition within the next decade. In conjunction with the IMO, it's important for me to mention the crucial role that the United States Coast Guard plays in this regulatory environment. The Coast Guard acts as the main regulatory body for carrying out regulations set by the IMO. They also make up a very significant portion of the American delegation that consistently engages with the development of international maritime policy. They're in a very unique position to collaborate with allied pro-nuclear states to bring forward the necessary updates to SOLAS to more effectively regulate the developments in technology we'll see within the next decade, allowing the United States to become a global leader in the maritime industry as they work towards meeting decarbonization and energy goals. The final regulatory body I'll touch on today is the role of classification societies. Classification societies are authorized by flag states to coordinate with stakeholders to maintain regulatory standards in the design, construction, and survey of marine assets. In the United States, the American Bureau of Shipping, ABS, is the primary classification society that handles this responsibility. ABS is currently working with an award from the U.S. Department of Energy to assess their readiness in supporting vessels that integrate advanced nuclear reactor technology with the maritime industry. So, as I said, while my focus today has been on maritime regulation, it's very important to note that a marinized prototype would require both the development of maritime and nuclear regulation. On the nuclear side, the American commercial market has already begun the initial process to develop advanced nuclear reactors, including reactors that are potentially suitable for maritime use. Under the U.S. Department of Energy's Advanced Reactor Demonstration Program, ARDP, Core Power is a partner in a consortium with nuclear developers and operators working towards an advanced reactor prototype. This prototype is envisioned to be compliant with both nuclear and maritime regulations, as they develop for this emerging sector and can be utilized to meet the transportation demand, both domestically and later on subject to export control restrictions in overseas jurisdictions as well. The American maritime market would most likely be the first application for this marinized prototype. The market is responsible for transporting goods through the inland waterways, the Great Lakes, and along the coasts, and is vital to the American economy, employing over 150,000 people. The Great Lakes region alone is responsible for transporting $80 billion in cargo. Now, some of these vessels would need to be very large, too large to navigate in through the St. Lawrence River from the Atlantic Ocean. An opportunity presents itself here to develop shipyards to build new vessels for this region to prepare for the future replacement of the aging vessels currently in use. Now, investing in this technology and the infrastructure needed to support it in a regulated economic environment is an important opportunity. It would allow for the United States to strengthen its capabilities and become an international maritime leader. While these regulations do require updates and to incorporate advanced reactor technology, there are precedents in place that can help facilitate these regulatory updates. The NS Savannah was an ABS classified commercial nuclear vessel that was classed from 1962 to 1972. During that time, ABS developed guidelines for the operation of this nuclear powered vessel as it transported cargo and docked in commercial ports. While it's currently being decommissioned in Baltimore Harbor, its existence and commercial use creates an important baseline for the application of nuclear powered vessels in the future. This is carried out today through ABS's new technology qualification process, meant for technology that does not have active regulations for marine application. ABS granted an approval of principle for a molten salt reactor to be used on a floating nuclear power plant earlier this year. And this is a very important step towards the regulation of nuclear application in the maritime industry. To conclude, I just would like to say again that it's important to understand that while the regulatory environment may seem limiting, it provides a unique opportunity to develop American capabilities without fear of competition and clear potential application. We can use this strength to bring forward updated maritime regulations on an international scale, becoming a global leader for this advanced technology. Here at Core Power, we're prepared to work within the industry and support the necessary regulatory changes to support American growth and success. Thank you very much. And back to you, Toby.
Well, many thanks, Sanjana. Some very interesting points you make there, particularly for me around the updating of SOLAS Chapter 8, which may involve the United States Coast Guard, along with other flag state representatives, of course. And as an aside there, we're very engaged with the Maritime and Coast Guard, Marine and Coast Guard Agency here in the UK on this topic as well. So if I could bring Mikhail and Rory back in here now, which is great. I just wanted to sort of ask you an open question, really. What do you guys think about what you just heard? I mean, certainly the work that ABS are doing under their Department of Energy grant is clearly quite a significant development in this space. Sanjana just mentioned that they're involved in a floating nuclear concept design being developed in Korea that was announced recently. What do we make of that? And to what extent will class involvement here unlock the door for a regulator that we haven't covered yet today, which would be the role of the insurer, for example? But I'll just throw it open to you guys for now.
I can start off, Toby. So the conditions for insurance to be in place means that all vessels have to be classed. And everyone in the shipping industry knows this is the same with aircraft and vehicles on the road and trains, etc. They need to maintain a certain standard, and that standard is set by statute and then enforced by the classification societies. And that, in order to get insurance, you need to be in class, so to speak, and that class needs to be of the highest level. So therefore, the class societies really is the final piece, if you like, before you move towards commercialization of this, which is important then for the class societies to be involved at an early stage in the development of this, so that they can understand not necessarily the actual reactor technologies, because they will treat that very much like a black box. They assume that once you start classification of vessels, floating platforms, offshore structures, etc., with new nuclear on it, that the reactor will already have been licensed. So they would defer that to the licensing authorities. But then it's the installation, it's the interfaces, it's the ecosystem, the training, the procedures around how that is managed in different conditions, normal everyday conditions, as well as, of course, accident conditions and avoidance of that, to give then the assurance to the insurance industry so that that can be covered in the right kind of way. And of course, around that sits liability regimes, which are international statutes, etc., that are sort of partially available for this industry, but needs to be evolved into the modern day. So this is an incredibly important part of it. And I think also, just to add one final point to this, is that American Bureau of Shipping in particular is a key part of this in the United States, because the Department of Energy is not only supporting the development of new technologies, but they're supporting that ecosystem around it as well. So the grant that's given to American Bureau of Shipping to spend the next 2-3 years, creating and mapping that pathway towards prototyping, deployment, demonstration, and the commercialization of these technologies is an immensely important part of it. They sit really as spider in the middle on so many things, and it's great to see that the government actually steps up and makes this happen, rather than leaving it entirely to the commercial market to come with a solution.
Yes, I agree. And just going back to that point on you made on class and insurance earlier, we've seen, haven't we, that when a new set of class rules are being developed, and it would be a fledgling set of class rules for new nuclear maritime that we're discussing, actually the insurance industry is sort of a sort of sounding board really for class. When a development set of class rules go out to stakeholders and the wider industry for comments and evaluation, it's actually the insurance industry that acts as one of sort of the proving grounds for some of the concepts. So I think we've made that point. I guess, Sanjana, you also mentioned Jones Act there in your talk, and something that we noted recently, that the Jones Act, of course, is not a universally loved piece of legislation. It has its supporters, plenty of supporters, but it also has a few people who criticize it, certainly in recent times as well. We've heard it sort of described as an outdated industrial policy, and I've even read recently that there is some think tanks have called for it to be not repealed but tightened, in the sense that when new buildings are handled in the United States, they would even have to, certain electrical systems would also have to be built in the United States. And think tanks have called for a national shipyard to be developed and put under the control of MARAD, which was one of the other regulators that you mentioned there. So I wonder what you thought about that. It can't be easy it would be almost impossible to repeal something with the longevity of the Jones Act overnight. But do you think it's something that might be adjusted or changed somehow over the coming years? I wonder what your thoughts were.
I will say that it's very true that the Jones Act has both supporters and people who are very for the repeal of it. I think at the end of the day, the main purpose of the Jones Act, to bolster the American economy and shipbuilding industry and protect American jobs, should and will be still central to the legislation. There are exceptions that are constantly processed towards the Jones Act. So a potential future that I see occurring would be the development of further exceptions and the incorporation of more flexibility within the regulation, but not the complete repeal or tightening of it, to ensure this still development of shipyards and the protection of American jobs that it focuses on. McCall or Rory, did you have any other thoughts to add?
I think in terms, obviously, the Jones Act and what we're proposing, the Jones Act could provide an incubator for the sort of first deployments of US reactors inside US national waters, whether that's providing floating power or whether that's on sort of moving, whether it's oil down from Alaska or providing, goods to Hawaii and Puerto Rico. It's not a showstopper for this technology and could provide sort of a way to get those first deployments out there.
Yeah. Absolutely. Okay. I'm actually going to take one question from the floor here, because when it comes to that sort of leads in quite nicely when you mentioned incubator timelines. I had a question in, is there any timeline on the approval, development and implementation of nuclear powered commercial ships on the US East Coast? I don't know who feels willing to start on that, but a question on timelines there.
Well, I can pipe in on that one, Toby, and actually it segues quite nicely into the remainder of the presentation that I was so rudely cut off from earlier, and I do apologize for that. I think the timeline here, we're talking about prototyping, and we're talking about demonstration, commercial demonstration in the first half of the next decade, really 2030 through to 2035. I think there is there's still uncertainty, and not uncertainty, I wouldn't use that word lightly, but we don't know at this stage exactly how things are going to play out with the size of the order book, who the customers that step forward to do this on the US East Coast, US Gulf Coast, I mean all over the United States for that matter, how that actually plays out. This could be something which is first deployed on a vessel that's owned by the US government, for example. That's a possible thing, and then it moves into things which are more closely related to that, and then moves into the full commercial market after that. So, but I think when we talk about commercial prototyping and the actual ability to prove exactly how this is going to work, improve all the benefits of how this would work, we're looking at 2030 to 2035, somewhere in that window. But that segues actually quite nicely into what I was going to do in the rest of my presentation. So Toby, if you don't mind, I'll crack on.
I think that's a good idea. Now your connection seems to be a bit more robust. Fingers crossed.
Thank you. Yes, I fed the squirrels that are running the wheel that's feeding our internet here in London. I think what this really comes down to is climate tech leadership, right? So the shipping industry is calling out for somebody to take that leadership, not just in terms of a transition away from fossil fuels, but a transition towards something that is cleaner, better, faster, and potentially cheaper as well. I mean, at the end of the day, progress is what we're all after, and progress is what's going to win. So, if we see the energy transition as one that's not just transitioning out of fossil fuels and out into the wilderness, so to speak, but one that transitions towards something that actually performs the same function but does it better, it really is nuclear. That is the standard solution for this. So that climate tech leadership that this actually implies is something that can create a whole new set of capabilities for those that deploy it. And of course, with the United States taking the lead here, we would of course like to see other nations taking the lead as well, but the United States seems to be the one that's stepping out to do this first, and we're participating in that. We can see how that would work. So just put this into context, right? We've got, according to the United Nations, UNCTAD, we've got 98,142 vessels on the water, which are larger than 100 gross registered tons. So that's everything from something fairly small up to the very largest ships in the world. Now, 178 of those 98,142 ships are flagged in the United States. Now, less than 90 of those trade inside the Jones Act fleet. So you're talking about a very small percentage of the ships in the world that are in fact US ships built in the US, operated in the US, operated from the US on US flagged. The other bit of statistic that I think everyone should be fully aware of is that of these 98,000 ships that are out there, which consume somewhere around 350 million tons of fossil fuel, marine fuels every year, only 7,300 of them consume just over 50% of all that fuel. So you've got a concentration in a small number of vessels that consume half of all of these fuels. So if we're going to cut our emissions in half, clearly this is the segment to focus on. Of course, it stands to reason that these 7,300 ships are then the largest ships that exist out there, the largest tankers, bulkers, container ships, PCTCs, cruise ships, etc. Now, here is a market opportunity, I think. If we're looking at climate tech leadership that has an impact worldwide, and you've got a US fleet that is really a shadow of its former self, the opportunity here is to use this technology that we're developing as a disruptive technological catalyst to create a stronger US shipping industry inside of this segment. So how many of those 7,300 ships that will, of course, have to be replaced over the next 15 to 25 years can this industry then stand up to do? And could it do it in such a way that's competitive with shipyard capacity around the world? We think that's definitely possible, because here is a new way of doing something that can't be done elsewhere, at least for the time being. And it's really how progress is made through innovation like this. We also believe that kind of the energy security that this technology provides, combined with that transport security you get from having available a large fleet of commercial vessels. I mean, look at China, look at Japan, look at Korea, look at the big shipping nations. They've got big fleets available to them. It adds to national security. It also, I should say, one of the key reasons why the global shipping industry is exempt from the new global taxation rules, because they in fact are a key component of national security, and as a result are then exempt from those taxation rules. So, shipping doesn't pay much tax. So we believe that US-built new nuclear can, of course, not just power these large ships, but also be part of that solution to create the synthetic fuels that are required for the remainder of that fleet, the 90-odd thousand ships out there that's mandated to move away from fossil fuels and into synthetic fuels that release less greenhouse gases and carbon dioxide into the atmosphere. So there's a solution there really for both of these. I think, and I'm careful not to be too brave here, but mirroring something that Sanjana just talked about, we think of the Jones Act really as an essential part of the US shipping industry as it is today, simply because it provides a life support system for it. If you took it away, the industry would wither away and die very quickly with foreign competition. If you don't take it away, you leave it in place, of course, you're prolonging that life of the patient, if you like. It continues to shrink and it continues to age, and the incentive to grow it back up again and create something new out of it is sort of missing without that specific technological and disruptive catalyst that's in there. I mentioned before, but it's important to put this into context, that more than 50%, this was as of last month, more than 50% of all global orders are now in Chinese yards. And that means that China are outperforming the United States more than 100 to 1 when it comes to shipbuilding. So clearly there's an opportunity here. There's a challenge and an opportunity both. The fact of the matter is the US, like any large country, needs to have a domestic fleet, which it needs potentially for wartime requisition and also peacetime security. You need to have a fleet available if you're going to use it for requisition purposes by the military. And I think that disruptive technological catalyst that we're talking about here is needed for this industry to come off life support, can breathe life into the Jones Act again, and then that can make that market thrive. And I think that's the key part of this. Now, the technology that we're developing together with our partners in the United States is part of two US government programs. One is the Advanced Reactor Concept. So we did the initial testing and put together the integrated effects testing facility supported by TerraPower, Southern Company, Core Power, and others. And that really is the basis of this molten salt reactor program in the United States for United States use. And then that moved into the Advanced Reactor Demonstration Program that we've mentioned before, which is really where we're building the first experimental reactor that's being built in a national laboratory in the United States, and should be ready in the next 3 to 5 years. Again, it's the same partners that are funding this together with the US government. So that shows commitment from the US government really to make this happen. So if you take that together with the funding of the American Bureau of Shipping to lay the pathway and to discover how the ecosystems can be built around this for marine deployment, I think we've got a winning formula. That development roadmap for this particular technology started in 2016, goes through to 2026, really on the experimental side, and then moves into prototyping post that, which is why we're talking about 2030 to 2035, really as where the commercial deployment and the expansion of that program would happen. Where we are today, well, we've built an integrated effects test facility on the west coast of the United States, which is the largest molten salt test facility ever created, and it give us a phenomenal amount of data on how the actual, and inform us of the design aspects of the reactor itself. This is an incredibly important piece of work. It's an $80 million facility that's been funded partly by the government and partly by us on the private side. We're very proud of this facility. It looks just as awesome as it is. In terms of the development timeline, then, again, we're looking at that period to, up to say 25, 26 for the experimental reactor to be ready. That's where this integrated effects test is leading into, and then creation of that small reactor, and then the design completion of the marine demonstration in the years following that. There's an awful lot of testing, an awful lot of work that has to be done to put that together, and we're looking then at the first marine deployment sort of in the middle of that window I described earlier on, between 2030 and 2035. This can be done quicker, but there's a lot of bureaucracy around nuclear. There's a lot of checks and balances that have to be overcome. So, with the right kind of will and the right kind of support and the right kind of, financial incentives in here, we believe this can be done faster. But this is the timeline we're working to at the moment. And then, of course, serial commercialization from 2035. The commercial markets, the demand signals from the commercial market is now so strong that we believe that private investments, Department of Energy, potentially others, then help to de-risk that commercialization timeline and bring that, nearer to us in time. Now, I'm sure you'll talk about this afterwards, Toby, but I just wanted to make sure that we got this on the agenda. We're running a new nuclear and maritime summit in Washington, D.C. on the 15th of June of this year, and it's by invitation only, but you're very welcome to contact us for an invitation, and it's those that are specifically interested in and engaged in and involved in any aspect of the U.S. shipping industry, the sort of innovative economic technological catalysts that we've been speaking about here today on the nuclear side, regulatory side, etc. That should be coming to the summit. It's a full day event. We'll have a lineup of phenomenal speakers and topics, and it should be a cracking day. So with that, Toby, I'm going to stop sharing and then hand it back to you.
Brilliant. Thank you very much, Mikhail. Always used to sort of unpack those themes, even if it's not first up, and we've had to sort of do the presentations in a slightly different order to how we envisaged. But I think my main takeaways from that are still that clearly this new set of capabilities really could be a Kickstarter for, firstly, a new paradigm for coastal industry, and then secondly, perhaps a reinvigorated Jones Act fleet. So a potential then to take it sort of further overseas after that, obviously going some way into the future there.
It's not every day, Toby, that you come across an opportunity that has the kind of potential scale that this has, right? So here you've got a fundamental, a very important national security industry like the shipping industry, and you've got something which is as fundamental to climate change and global warming and energy security as nuclear, and you take the two, you combine them into one, and you create that climate tech leadership. I mean, the opportunity here is, I can't think of anything larger than this since semiconductors were brought to market many years ago.
That's right, and there's this sort of we've talked about this a little bit in previous programs as well. But there is this inevitability about the marriage of nuclear and maritime. Both industries have something that the other one wants and needs. So I think that's a key part of it as well. Just bringing in the rest of the panel there, I was wondering, to what extent do you agree that what we've just heard from Mikhail, that sort of having the technology built, licensed, and deployed in the United States, that sort of triumvirate of activities is at least initially sort of the ideal proving ground? Are you on the same page there?
I think with this technology, so people can have the confidence they need in it, so it can become deployed across globally. Having those first deployments built and deployed and legislated for and regulated in the US is sort of the ideal first sort of deployment. We need somewhere where there's a strong maritime base and a maritime administration, and a strong nuclear base and a strong nuclear administration, and the US is really the top sort of option we have there.
And one question that's come in from the audience here, or the attendees, which I'm interested in, is what, in our opinion, is the most limiting roadblock in commercializing new nuclear in the US maritime industry? One idea that's been put forward is the struggles with staffing and manpower in various organizations. Are there pathways there that exist to get future generations interested and excited in this new industry to meet the timelines that we've described?
I think it's really a combination of things, Toby. I don't think there's one outstanding challenge apart from all the challenges that are there. You know, this is not easy. It's not supposed to be easy. It's hard. It's difficult. It takes time. It costs a lot of money. So there are challenges in every possible aspect of this. But if you take those challenges and you put them all together in a timeline where you've got to put a new product together for a specific customer with a specific workforce in a specific location, regulatory regime, and create a durable, reliable, maintainable product offering at a reasonable cost, that is the same kind of challenge that any new industrial innovation has. The diesel engine, the steam engine, the semiconductor, all of these things were there. The difference, of course, is that you don't develop nuclear technology in your basement and then bring it out when it's finished. This is something we do in specific laboratories made available to us, and we do it over a very long period of time. And as a result, we have these extensive debates around it. So I would say there are no sort of standout challenges, but if you add them all together, it is a very big challenge indeed, which is why, it's important that we work very hard on this for a long time, which is what we're doing.
Yeah. And a very quick question about the size of the global opportunity. Now, a big question, and some figures have been thrown around. 4 trillion, is that a reasonable estimate? I'm not sure what you'd say to that. I mean, I guess it depends whether you're considering floating nuclear power plants in addition just to the pure shipping market, or how you sort of divide up that cake. But 4 trillion certainly seems a big number. I don't think we'd put that sort of figure on the shipping market as such, but maybe if you include the wider ancillaries, it's possible.
The best number I've heard from economists that have been looking at this separately from us, really, they're looking at what's called an addressable market. In the future, you don't know. I mean, if anybody could guess what the oil industry would become when oil was first discovered, I have no idea what those numbers were. But the best numbers we've heard from professional economists on this is 6 trillion. So that's about 12,000 units in an addressable market between now and, say the next 30, 40 years.
Pretty significant. Okay, now we're going to move on. Our final short talk today is from Rory. This is going to look in a bit more detail at the topic of a US manufacturing base and some considerations related to the US shipbuilding sector. Rory, we've sort of seen some contract awards recently going the way of US yards for some quite specialized ships that will service offshore wind sector in the United States. So it's perhaps that sector, along with a resurgent oil and gas support vessel industry, and on top of that, presumably some increased defense spending. Do you think those three things together likely to be the sum total of any improved sort of demand picture for American shipbuilding, or is there more in play than that?
Yeah, I think without a major technological game changer for US shipbuilding, those sort of topics you just mentioned are really the sum of what you can expect any growth in the sort of next decade. And that growth is not going to be, game changing in terms of, allowing it to compete with, foreign yards in the Far East. And that's sort of one of the things I want to talk about today. So just quickly introduce myself. I'm Dr. Roy Megginson. I'm Director of Analytics here at Core Power. And what I want to do today is really do a deep dive into one of the things Mikhail was talking about earlier in terms of US shipbuilding. Now, I'm sure many of the people on this call who are involved in the US maritime industry are well aware of this current state of the US shipbuilding industry that has really been in sort of almost continuous decline since its peak just post-war. It's now very limited in terms of its actual use in commercial vessels, while obviously the defense is a separate sector. And it is now only used for the production of offshore support vessels, partly for the growing offshore wind industry and the existing oil and gas industry, as well as a small amount of Jones Act fleet building for those vessels that transport goods to Hawaii and Puerto Rico and from Alaska. However, as Macau was talking about earlier with the aging age profile of those vessels, with people keeping them on for longer to save money rather than buying often expensive American new builds, we've actually again seen a further decrease in the total number of vessels produced. To put this in a global context, this shows the gross tonnage built in 2022 in terms of countries. As you can see, you can barely see the United States, just 0.05% of all gross tonnage built, compared to 90% built in China, South Korea, and Japan. US yards have up to this point being unable to compete with the yards in East Asia on price or build speed, and are going to need significant changes for them to sort of see significant growth in the near term. That's not to say that US shipbuilding has no strengths. The US does have an existing industrial base for the production of military vessels, including the US nuclear fleet, in both nuclear aircraft carriers and nuclear submarines. You see those built in Newport News in Virginia and also up in Connecticut. This, as well as the existing strong US nuclear industry, provides a possible, basis on which a commercial nuclear shipbuilding industry could be built. The US is really one of the few countries with the experience in nuclear and the experience in maritime that could do it. And this could really be a revolutionary technology for the industry. I know up until this point, we've mostly been talking about nuclear power for direct ship propulsion, but it's worth sort of taking a step back and looking at it in a broader, almost more international context. Floating power barges, in terms of providing clean, reliable electricity anywhere where they're deployed, are a possible real exportable product for the US maritime industry. Having reactors that are licensed and regulated by US authorities, so people can have high amounts of trust in them, means that they can play important roles in decarbonizing the electricity grid of both domestic US as well as American allies across the globe, providing a much more reliable green source of electricity than reliant on fossil fuels, which we've seen with recent events have been very easily affected by geopolitical shocks like the war in Ukraine. This is potential for the US to build a massive new industry at the heart of both the global economy. And this has kind of, in many ways, been done before. The US nuclear submarine program has seen significant time and cost savings from moving to modular shipyard construction. So we know the skills and experience are out there in the industry to build these nuclear facilities as an exportable product base. If we can use these skills for a commercial product and have that exported globally, it really will grow the maritime economy in the US. So I just want to sort of go over our key point. Marine nuclear offers an opportunity to create a high-tech exportable product for the US economy. That means high-quality manufacturing jobs across the US, not just in the shipyards themselves, but also in the upstream of this product. So that's in reactor development, reactor licensing, it's in steel manufacture. It's a way to provide a massive GDP boost throughout the US economy. It'll also allow nations to aid decarbonization with green nuclear power, rather than a country without an existing nuclear ecosystem or nuclear regulator having to build up those competencies over a long period of time when they were going to have to rely on fossil fuels. It'll allow them to use the already existing high quality standards in the US, have an exportable reactor and plug it straight into their grid, providing the electricity they need to meet their decarbonization goals. And finally, it should put the US at the center of a vital new industry, making it a true sort of energy superpower in the coming century. I hope you can sort of see what the future we're looking for in terms of US shipbuilding, pairing that with nuclear power. I'll sort of hand you back to Toby to just any last questions that we have about this. Toby, you're muted.
Sorry, always going to happen once. Thank you for that. Interesting to learn more on this topic, always about shipbuilding and US shipbuilding in particular. So I've heard from all our sort of panelists individually now. They're all back up in this final panel and Q&A session together. So we've examined some of the regulations. We've looked at the concept of a reactor manufacturing facility, potentially co-located with a shipyard and then working hand in hand on modular build and construction. And I wanted to ask you really, is there one element of the things that we've discussed today that you'd like to point to and potentially recap on or expand on, or is there anything that needs sort of fleshing out from your perspective? I suppose one aspect really is that this concept, the whole concept of maritime nuclear seems to sit quite sort of squarely in a sweet spot, if you could call it that, of US industrial policy. And I just wondered if you had any sort of further comments to make on that as we close today.
I've got one thing I'd like to put in there, Toby, and that's something that most people don't know, and that's the export control restrictions around nuclear technologies, from any country, actually. It's not specific to the United States. It's the same here in the UK and France and all other countries that have a nuclear industry. But export control restrictions around nuclear propulsion are especially difficult because of the nuclear navies that are out there. So we have specific rules that sit in the background that prevents you from taking US nuclear propulsion systems and exporting them without very specific, very detailed authorizations to do so. So the ability to do this, so and again, this is both a challenge and an opportunity. It's a challenge for the international community, very big challenge for the international markets, but it's an opportunity for the US here to show that climate tech leadership again by creating, if you like, an extension of that US capability out on US flagged vessels to start with. Then that can be, once that's established, can be exported to nations where that level of trust exists, for those flag states to be able to run those ships. I believe the UK is definitely one of those. I believe Japan could also be one of those. So you've got that transatlantic, that trans-Pacific alliances that are formed around this. It's not going to go everywhere. Now, I think it's very different on floating nuclear power. Now, there's nothing stopping any country that has a nuclear capability, nuclear energy capability, to create a floating nuclear power station. So, here in the UK, for example, you've got that opportunity to reinvigorate the shipbuilding industry here. It's certainly not in a great shape either, if we can put it that way. I think it probably looks up to the US shipbuilding industry as it is today. But there are opportunity there to do things there as well. The third point I'd like to make is that you do have some extremely capable US shipyards, but they are looking for work. They're looking for the kind of commercial work that they can do to differentiate themselves from the mass production yards in Asia, right? You've got yards like Philly, for example, which is an extremely capable yard that now does a lot of naval work. You've got the naval yards themselves that are quite busy with work that they're doing there. But you've got commercial yards, and those are straddle the fence as well, that are very capable, and they could well do with the investment from a new market that comes in to do something different, right, and create that differentiating factor. They're in the perfect position to do so. They've got the facility, they've got the workforce, and they need investment, and they need the new orders. So I would say all the conditions are there for this to be done, and for it to also then gradually also become an international market.
Absolutely. One aspect we haven't covered today, and I wanted to touch on very briefly at the end, is funding. This market generally represents an awesome sort of funding opportunity and the possibility to put in place some very sort of large scale public-private initiatives. And separate to that, you've got private equity that has sort of been getting slowly primed over the years for some very large scale ESG investments that also have some long timeframes. So I wondered how you saw that fitting into the picture over the coming years as well.
Again, I can probably help answer some of that, Toby. We see that point at which the prototyping and demonstration of how this actually works, which is different from where we are today. And now we're still, putting the machines together, putting the units together, testing every component to make sure that it works at the highest possible quality level, so that it is virtually accident free. once we get to that point where you start to prototype and deploy those for specific customers, and you can come and touch it and feel it and see what the capabilities of building this out can lead to, and that scalability, it was referenced earlier, $4 trillion, $6 trillion, what we're talking about, a large scalable market. That's when the institutional large money starts to step into this. I mean, financing projects, financing, specific assets that get built, financing infrastructure investments in yards, supply chains, manufacturing facilities, jobs creation, etc. That's where the big money comes into it. At the moment, all the money is there for us to do this. We're fully funded to develop these machines, and it's not there's not really the need for that huge amount of money yet. But once that's available, and once you get to that point, I think it's a starting gun for large money to come into the market.
Excellent, thank you for that. And a final question for Rory, I think this one would be for you. You mentioned there, sort of in your presentation, this concept of military and commercial. How simple would it be to sort of transduce or convert some of those military to commercial skills? I'm assuming we're talking here about shipbuilding rather than crewing competency.
Well, I should say I think the crewing competency is actually also something you'd be very easily placed to transfer those skills into crewing for crewing of commercial nuclear vessels from nuclear vessels. In terms of the shipbuilding, essentially the complex nature of the builds in the US defense industry, in terms of working with nuclear safely, hopefully with the advanced reactors, that'll actually be a couple of degrees more simple than we see with military vessels. So we should see a really, I don't want to see easy transference, because obviously there will be a degree of retraining, but it should provide an exciting opportunity for those people with those skills to develop them and expand into new markets.
Yes, absolutely. I totally agree there. Right. Thank you all very much to our panelists for your contributions today. And just to close today's program, I'd like to give you a quick flavor of what the next month or so looks like from our perspective. Next week, we'll be presenting at the CMA shipping event in Stamford, Connecticut, where myself, Sanjana, and also our US country head, Tony Houston, will all be on hand. So if any of you are planning to be there, please look us up. And in terms of other events that we're running that are related to our client program, you heard this from Mikhail earlier, but just to recap and reiterate on that, our Washington Summit is in almost exactly 3 months' time. It's going to be held on the 15th of June, and we're currently planning the details for this event now. It's going to be a full-day program, which will be quite product-centric. And what I mean by that is that we will delve into aspects of not just the reactor technologies themselves, but also what sits around the reactors, their ancillary systems, their interfaces, power conversion, machinery, shielding, etc. So to try and give you as round a picture as possible as what you could get from a core power system. And that system, of course, once it's integrated into its host asset, can then perform a multitude of functions: clean power and industrial heat in the case of a floating nuclear power plant, which, as Rory will tell you, can be harnessed then for a wide variety of use cases, everything from synthetic fuel production to desalination of seawater. And then taking that further, in the case of a nuclear electric ship, operating under a US jurisdiction, this means faster ships, fueled for life, carrying more cargo, and acting as a forward floating power station when they're needed. Now, our Washington Summit is going to be the first ever full conference to take place on maritime nuclear in the Americas. So please keep an eye out on our social media channels and on our homepage, of course, for more details on that. But for now, all that remains for me to say on behalf of all of our panel is we hope you've enjoyed today's program. We appreciate you taking the time out of your day to join us. Have a good finish to your week. Thank you very much again, and goodbye.